Okay, good morning, good afternoon, good evening, good night, depending on when you're watching. We are going to work through the exercise on slide 29 of lecture set number 2. In this exercise, we are computing the mean, the median, and the mode. Our data are the number of airline passengers that traveled internationally each month in the year 1960. So we actually have two variables in this exercise. We have the qualitative variable, which is month. And this would actually also be an ordinal qualitative variable because there is an intrinsic order that's associated with the months of the year. Okay, so we have variable 1 is month, and this is a ordinal qualitative variable. And we have variable 2, which is the number of passengers. Okay. All right, so for variable number 1, we can only compute the mode because it's a qualitative variable. Okay. And for variable 2, we can compute the mean, the median, and the mode because it's a quantitative variable. All right. So let's start by computing the mode for the qualitative variable, which is the month of the year. So in this case, what we're looking for is simply the month that had the highest number of airline passengers. So if we parse through the data, we can see that the largest number is 622. So the month with the largest, the month with the highest number of passengers traveling internationally is July. So therefore, the modal month is July. All right. And in this case, what we can say is July was the month with the highest number of passengers traveling internationally. Right. I'm just going to fix this up here. Okay, so the modal month is July. Okay, and then this over here would be our interpretation of this value. Okay, so for qualitative variables, we're only able to find the mode. We cannot compute a median or a mean for a qualitative variable. And in this case, the qualitative mode is simply the month that appears most often, or the month that had the most number of people traveling in it within the context of this problem. Okay, so now for variable 2, we can compute all 3 values. All right, so the first thing that we're going to do is actually arrange the data from smallest to largest. This is useful when we're computing the median actually it's essential when we're computing the median, but it's also helpful when finding the mode, because when you arrange the data, any value that occurs multiple times will end up beside each other. So they're easier to pick out. All right, so if we start ordering the data, we're gonna have the smallest number first, which is 390. This is followed by 391. This is followed by 417, which is followed by 419. Then we have 432, 461, 461 again, 472, 508, 535, 606, 622. Right? So this is our order data. Now we can see in the context of the mode, it's very easy to pick out the mode here because 461 occurs twice. And this is the only value of the 12 values that occurs more than once. So the mode for the second variable is 461. Okay, and then the interpretation in this case doesn't have a lot of meaning, but it would essentially be something along the lines of we observed 2 months where we had the same number of airline passengers traveling, or there were 2 months of the year that had the same number of airline passengers, or there was 2 months of the year where the same number of airline passengers traveled. And that's the only time that this occurred. Okay. So there were 2 months where the same number of airline passengers traveled. Right. Okay, now the next thing we can do is compute the median. So in the case of the median, we have 12 values, right? So starting with 390, working all the way up to 622, that gives us 12 different values. So if we wanted to, we could take our ordered data here. Could pull it down here. We could label these from 1 to 12 just for clarification. Okay. Now the median, as we know, is the value that splits the data into 2 equal halves. So we have 12 values. So the median is going to be right here. Right? And on each side of the median, we have 6 values, and therefore that's split into an equal half, right? 12 values total, split in half gives us 6 and 6. So the median is in between the 6th and the 7th value. So in this particular case, the median is going to be the average of observation 6 and observation 7. Okay, so the median is equal to 461 plus 461 divided by 2, which is 461. Okay, now in terms of interpretation, what is the median telling us? It's essentially telling us the midpoint of how many airline passengers travel in each half of the year. So for half of the year, less than 461 passengers were traveling internationally, and for the other half of the year, more than 461 passengers were traveling internationally. So for half of the year, less than 461 passengers traveled internationally in the other half of the year, more than 461 passengers traveled internationally. Okay, so it's the halfway point in the data, and it's telling us what occurred in the bottom half of the data and what occurred in the top half. So again, in this case, how many people traveled below the midpoint and how many people traveled above the midpoint. Okay. So the last value that we need to compute is the mean. So the mean, as we know, is just the sum of all the values divided by the total number of values in the data set. So the mean is equal to 390 plus 391 plus 417. Okay, and then the dot 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 just means include the other values. So we're going to keep adding across all the values in the data set, plus 535, plus 606, plus 622. Right? And then we're going to divide by 12. So we've added the 12 values that we have together. We're dividing by 12. This gives us 476.167. Okay. And here, what we can say is, on average, 476.167 passengers traveled each month in 1960. All right. Okay, and then up here, I should have mentioned that we are working with a discrete quantitative variable. Okay, so we're counting the number of people that traveled each month. That's quantitative and discrete because it's a whole number count. We're counting people. All right. Okay, so that is our illustration of computing the mean, the median, and the mode for a quantitative discrete variable. And we also computed the mode for a qualitative variable. For qualitative variables, we are only able to compute a mode. For a quantitative variable, we can compute all three values. In some cases, the quantitative data may not have a mode. So there might be no value that occurs more than once in the data set. In that case, we would just state there is no mode. It's also possible that you observe quantitative variables where there's multiple modes. In that case, you would just state all of the different modes. All right, as always, if you have any questions, please let me know, and I will chat with you later.